Hi everyone, this is Abdullah with you. I will talk to you about a paper about label only membership inference attack, which is presented in 2021 by Christopher and others. This is a final project for data science and cybersecurity course. First of all, I will talk about machine learning. What is machine learning? Machine learning is an algorithm that is able to learn from data. There are two stages in this learning. One of them is training stage, which is building models from data. The models have tunable uh, parameters that can be adapted to absorb the data. The second stage is inference stage. These models have been fit to observably seen data. They can be used to predict and understand aspects of newly observed data. Type of learning. There are many types of learning. First of them is supervised learning, which is learning from labeled data, like spam classification. Second type of learning is unsupervised learning, which describes structure in unlabeled data, like document clustering. Third type of learning is reinforcement learning, which is learning by doing with daily reward, like chess computers. Supervised learning, a model is trained to predict some class label Y with a given input data X. Commonly, X maybe is image or sentences, and Y is the corresponding label, like a digit from 0 to 9 or text sentiment. There are two types of supervised learning: classification and regression. Model architecture. This study focuses in the neural network function composite of the linear transformation layer, each flowing by nonlinear activation. The overall layer structure is called model architecture. Also, the learnable parameter of linear transformation are the weights. This is an example of neural network. It's input layer and hidden layer and output layer. The main type of augmentation are transformation for imagine classifier. First is rotation, reflecting, scaling and shifts, contrast, adjustment, cutout and add noise. Image classification, by using dataset which contain about 3,700 photos of flowers. This dataset contains 5 subdirections. I will implement the classification with import TensorFlow and other libraries, download and explore the data set, create a model by using the sequential model. Consists of 3 convolution blocks, and visualize the data using first 9 data. Also, image classification. Classify image of flower by using a TensorFlow sequential model to create a model. Also, we practical experience with the flowing concept, efficiently loading a data set off disk, and identify overfitting and apply techniques to mitigate it, included data augmentation and dropout. The basic machine learning, understanding the data, building the pipelines, and building the models, training the model, testing the model, and improving the model. Also, I will visualize the data configuration, the data set for performance, like it keeps the image in memory after they loading off disk during the first epoch. I use this piece of code also for data augmentation and training the model. I will training the model 10 epochs. Also, drop out, this meaning dropping out 10%, 20%, or 40% of the output units randomly from the applied layer. Compile and training the model, visualize training results, and we will do model summary and prediction new data. Now I will talk about attack. I will using label only branching membership privacy with label only code. First, data augmentation. The model can learn a more syntactically meaningful set of features by synthesizing the new data sample as augmentation of existing data sample. X of dash equal argument of X. Also, data augmentation can potentially touch the machine learning model to become invariant to augmentation. For example, rotationally transfer learning. Transfer learning is a common technique used to improve generalization in low data segments by leveraging data from source task. It is possible to transfer knowledge to target task. Commonly, a model is trained on the data of source task and fine-tuned in data from the output task. In this case, the neural network, it's common to fine-tune in the entire model or just the last layer. Membership inference attacks are a form of privacy leaking that identify if given data sample was in machine learning model training data set. I will do and use given sample X and access to training model H, the adversary using classifier or decision rule f of h to compute the membership prediction f of x, which is a value between 0 and 1. The goal that f of x equal 1 wherever x is training point. But the main challenge is creating the classifier function f. Shadow models. The original membership inference attack create a membership classifier f of x of h. The shadow model is turned to several local shadow or source model, assuming the advisor has access to data from the same or similar distribution as H's training data. Now the shadow model approach training the auxiliary source models H of I in this data. Since H of I is trained by the adversary, they know or not any data point was in training set and can be used to construct data of confidence factor for H of I with associated membership label M, which M is value between 0 and 1. The advisory trains the classifier F to protect the given H of I of X. Finally, the adversary queries the trade model H of to obtain H of X and use function F to protect the membership of X in H's training data. This attack strategy can succeed even without data from the same distribution of H and only with data from similar tasks. In addition, the training shadow models are unnecessarily applying some threshold prediction f of x of h equal 1, where x is a member, when the maximum prediction confidence maximum of h of I is above the threshold sufficiency. Toward label-only approaches, the adversary predicts a data point x as being a member of the training set with H classifiers, which when H classifies x correctly, the accuracy of this baseline attack directly reflects the gap in the model's training and test accuracy. This attack achieved an accuracy of half plus accuracy of training minus accuracy of testing over 2, where accuracy of training and accuracy of testing is a number between 0 and 1. The main goal to investigate how this sample baseline can be passed to achieve label on only membership inference attack. Indirectly membership inference. The indirect membership and inference concepts, investigates membership inference through the indirect access, wherein the adversary only queries h in input x of x dash that are related to x, but not x directly. And this label-only attack similarly makes use of information from Giroli H and data point related to X. The main difference is that label-only attacks, whereas the indirect member inference assumed adversarial access to the model confidence score, the label-only attack will be always to query and obtain the label at the chosen point X. Defenses against membership inference fell in two categories. First one, standard regressions techniques, weight normalization, dropout, or differential privacy have been proposed to address the role that overfitting play in the membership inference attack success rate. Defenses may be reduce the information containing in the model confidence, which are called confidence masking defense. For example, by truncated them to lower percent, reduce the dimension of confidence vector to only some top k score. To evaluation setup, first, full knowledge of the task. Second, knowledge of the training model architecture and training setup. Third is partial data knowledge, for example, access to disjoint portion of data sample from the same distribution as the target model training data. And finally, knowledge of targeted point label. Model architecture for computer vision task using two representative model architecture: a standard convolution neural network CNN and ResNet. A CNN has four convolution layers with activations. The first two layers is 3 by 3 convolution have 32 filter, and the second two have 64 filter with max ball in between the two. The compute logs feed the output target fully connected layer with 512 neural. This model has 1.2 million parameters. Also, using a full connected neural network with one hidden layer of size 128 and activation function. Also, the standard width of our recent 28 with 1.4 million parameter. For Texas 10 adult and location mimic this model but add second hidden layer matching the first. Adversarial knowledge, threat model knowledge, and task knowledge, training knowledge, data knowledge, and label knowledge. Query inference, there are defined two types of query inference with different level of response. First of all, full confidence factor. In query of X, the diversity receive the full factor of confidence score h of x from the classifier. The second type is label only. The adversary only obtain the predict label y equal argument max of I of h of x of I with no confidence score. Confidence mask defense description. There are three. First one, the model still output of vector prediction probability. For example, h of defense of x is a number between 0 and 1, and the absolute value of h of defense of x equal 1. The second is the model prediction are unchanged. For example, argmax of h defense of x equal argument max of h of x. The third is the noise confidence factor exists membership inference attacks. Prediction perfection. It trains a perfection model J that is applied to the output vector of the training model. This is on query X, the adversary received J of h of x. Adversarial regressions. This defense trainings the target model in tandem with difference membership classifier. This difference membership classifier is neural network that accepts both confidence factor of h of x of target model and the true label y that in one hot encoded. The difference membership classifier and the target model are trained in the tandem. First, the target model is trained few epochs. Second, the defense membership classifier is trained using the equal batch of a member and non-member, which should be different from holdout set from the target model. Third, the target model is trained in one batch of training data. That training model loss function is modified to include regularization term using output of defense classifier in training data. This regularization term is weighted by lambda. Any question? Let me know. Thank you for your patience.